Step into rediscovery, where cosmic marvels and the magic of science come alive. We've all seen the images, astronauts gliding effortlessly through the International Space Station, seemingly defying gravity. They move with such grace, as if they are swimming through the air, free from the constraints that bind us to the ground. It's a captivating sight, evoking a sense of wonder and sparking questions about the nature of floating in space. How do they manage to float so effortlessly? What is the secret behind this mesmerizing dance in the cosmos? But what if we told you that this floating is an illusion, that the astronauts are not truly defying gravity, but rather, they are in a constant state of free fall, orbiting the Earth at incredible speeds? The truth, as Albert Einstein unveiled, lies in a revolutionary concept known as space-time curvature. This groundbreaking idea changed our understanding of the universe and the forces that govern it. To understand this mind-bending idea, we need to shift our perspective on gravity. Instead of thinking of it as a simple force pulling objects together, we must envision it as the warping of the very fabric of space and time. Instead of viewing it as a force pulling objects together, Einstein proposed that gravity is a consequence of the shape of space and time itself. Massive objects like planets and stars create dents in this fabric, causing other objects to move along these curves. This is where the concept of space-time comes into play. It is a four-dimensional continuum that combines the three dimensions of space with the dimension of time, creating a complex and dynamic structure that dictates the motion of everything in the universe. So the next time you see astronauts floating in the International Space Station, remember that they are not escaping gravity. Instead, they are following the intricate curves of space-time, a testament to the profound and beautiful nature of our universe. Imagine a vast four-dimensional fabric woven from the three familiar dimensions of space length, width, and height, and the enigmatic dimension of time. This is space-time, the very fabric of our universe. Now picture this fabric not as a rigid backdrop but as a flexible, responsive sheet. Massive objects like stars and planets, according to Einstein, create dips or curves in this fabric. The more massive the object, the deeper the curvature. This curvature is what we experience as gravity. Think of a bowling ball placed on a trampoline. The ball's weight causes the trampoline surface to sag, creating a dip. If you roll a marble across the trampoline, it won't travel in a straight line. Instead, it will curve around the bowling ball, following the contours of the dip. This is a simple but powerful analogy for understanding space-time curvature. Planets orbiting a star aren't being pulled by an invisible force. They are simply following the curved paths created by the star's mass warping the space-time around it. A cosmic dance. Planets in orbit. Earth, for example, isn't being yanked towards the sun by a gravitational rope. Instead, it's perpetually falling towards the sun along a curved path dictated by the sun's distortion of spacetime. Imagine Earth trying to move in a straight line, but the spacetime beneath it is constantly curving, guiding it along its orbital path. This interplay between matter and spacetime is beautifully encapsulated in physicist John Wheeler's famous quote, "Matter tells spacetime how to curve, and spacetime tells matter how to move." Seeing is believing evidence of space-time curvature. Einstein's theory of general relativity, which encompasses space-time curvature, has been rigorously tested and confirmed through numerous observations. One compelling piece of evidence is gravitational lensing. When light from a distant star or galaxy passes by a massive object, the object's gravity bends the light's path. This bending, predicted by Einstein, can cause the distant object to appear in a different position, or even create multiple images of the same object. Astronomers have observed this phenomenon, confirming the warping of spacetime around massive objects. Freefall, and the illusion of weightlessness. In this section, we will explore the fascinating phenomenon that makes astronauts appear to float effortlessly in space. Returning to our floating astronauts, their apparent weightlessness is a consequence of both gravity and inertia. This unique state is not due to the absence of gravity, but rather the specific conditions of their environment. The International Space Station, along with the astronauts inside, is in a constant state of free fall towards Earth. This freefall is a continuous process creating a unique environment where gravity's effects are still present but not felt in the usual way. However, the station's high speed means it's also traveling forward at a tremendous pace. This forward motion is crucial in maintaining the station's orbit and the conditions experienced by the astronauts. This forward motion, combined with the downward pull of gravity, results in a curved path that keeps the station in orbit. Essentially, the ISS is perpetually falling towards Earth but never actually reaching it due to its high velocity. The astronauts inside experience a sensation of weightlessness because they are falling at the same rate as their surroundings. This creates the illusion of zero gravity, allowing them to float and move freely within the station. This phenomenon is a perfect example of how gravity and motion interact to create unique experiences in space. The universe's architectural fabric. Space-time curvature, far from being an abstract concept, is the very foundation of our universe's structure. It is the invisible framework that holds everything together, from the smallest particles to the largest galaxies. This curvature is what gives the universe its shape and dictates how everything within it interacts. It governs the motion of celestial bodies, ensuring that planets orbit stars and moons orbit planets in a harmonious dance that has been ongoing for billions of years. This cosmic choreography is a direct result of the warping of space-time caused by massive objects. It dictates the paths of light rays, bending them around massive objects in a phenomenon known as gravitational lensing. This effect allows us to see distant galaxies and stars that would otherwise be hidden from view, revealing the true vastness of the universe, and it influences the flow of time itself. Near massive objects like black holes, time slows down, a phenomenon known as time dilation. This means that time is not a constant but a variable that can change depending on the strength of the gravitational field. By grasping this profound idea, we gain a deeper appreciation for the elegant workings of the cosmos. We begin to understand that the universe is not a static place, but a dynamic and ever-changing tapestry woven by the forces of space and time. We begin to see beyond the illusion of floating astronauts and recognize the intricate dance of matter and space-time that shapes our universe. Every movement, every orbit, every interaction is a testament to the power of space-time curvature, and recognize the intricate dance of matter and space-time that shapes our universe. This dance is not just a random occurrence but a carefully orchestrated performance that has been unfolding for billions of years. So the next time you gaze at the night sky, remember that you're witnessing the profound influence of space-time curvature. Each star, each planet, each galaxy is a part of this grand design, moving in perfect harmony with the fabric of the universe. Remember that you're witnessing the profound influence of space-time curvature, the invisible architect of our cosmos. This unseen force is what makes the universe the awe-inspiring place that it is, full of wonder and mystery. The invisible architect of our cosmos. It is the silent force that shapes everything we see and everything we don't, guiding the universe in its endless journey through time and space. Thanks for tuning in to Rediscovery, where every journey reveals awe-inspiring wonders. Tap that like button, share your thoughts in the comments, and subscribe to keep the exploration alive.